So the other day we learned about substitution, and today you are going to learn about elimination. And so obviously we know that when you eliminate something, we get rid of. So our goal is to cancel out one of the two variables each time. So if we look at this first one right here, I have a negative y and a y. So if I add negative y to y, these just cancel out. So this is very important. So I'm going to think about just adding these two linear functions together. So if I add x and 2x, I end up with 3x. If I add negative y and y, they cancel out. So I end up with 0. And if I add 11 and 19, I end up with 30. So my new equation is 3x equals 30. Well, I know how to solve 3x equals 30. 3 times what gives me 30? Well, 3 times 10 gives me 30. So my x has to equal 10. But now I need to plug it back in and find my y value. So now I'm going to plug in 10 for x. I'm going to pick that first equation just because it's there. So when I plug in a 10 for x, now I need to solve for y. I'm going to subtract 10 from both sides. And I end up with negative y equals 1. Well, I need to get y alone. And in order to do that, I have to divide by a negative 1. And I should end up with y equals negative 1. And just to check to be sure, I can plug in my x and y into my second equation to see if it makes it true. And so I have 2 times 10 plus negative 1 equals 19. So 20 essentially minus 1 equals 19. Well, 20 minus 1 is 19. 19 equals 19, so this must work. If I look at the next one, the two variables that can easily cancel out are this negative 6x and 6x. So these two are what I want to get rid of. So I'm just going to add these together. And I end up with 0 plus 9y equals negative 9, because negative 10 plus 1 is negative 9. So I really end up with 9y equals negative 9. 9 times what gives me a negative 9? Negative 9 divided by 9 would be negative 1, right? Because 9 times negative 1 gives me negative 9. Well, now I need to plug this back in and solve for my x. So in order to do that, I end up with negative 6x plus 5 times negative 1 equals 1. So I'm going to rewrite this as negative 6x minus 5, because 5 times negative 1 is negative 5 equals 1. So I add 5 to both sides. And I end up with negative 6x equals 6. Well, negative 6x equals 6, divide by negative 6 on both sides. I end up with x equals negative 1. And to check this, to make sure I have both of these right, I can plug in -1 for x and -1 for y and see what I get out. So in that second equation, I'm just picking that randomly because why not? I can plug in like so. So I have -6 minus 4 equals -10. Well, -6 minus 4 is -10. So -10 equals -10. So I know that this is my right answer. So if I move on to a couple harder ones. Now, nothing here looks like it easily cancels out. We might have to manipulate it so it does. And so in order to do that, I notice that this -9y and this -9y could cancel out if one was positive. So if I multiply this top one by -1, this really turns into positive 2x plus 9y equals 25. And I'm going to rewrite the other one below it. So this is my newly turned positive equation. And when I add them together, now this 9y and this -9y will cancel out. So I'm left with -2x equals 2, because 25 minus 23 is just 2. So if I'm left with -2x equals 2, I have x equals -1. I'm going to plug my x value back into the equation. Either equation works. This time I'm going to do the bottom equation because why not? And I get -4 times -1 minus 9y equals -23. Well, -4 times -1 is 4. So minus 9y equals -23. I'm going to subtract 4 from both sides. And I end up with -9y equals -27. And then I'm going to divide by -9. And I end up with y equals 3. I'm not going to check this one because that's really just plugging both numbers back in. And I did that here for you to see on the first one and down here for you to see. So if you're confused, go back and reference those, right? How I checked it. But we can really just check by plugging both numbers in. So plugging in to one equation, -1 for x, and then the same equation, 3 for y. And we'll do this last example, and then I'm going to set you free. Well, I'm not there, but in theory, I'm going to set you free and you are going to try some on your own. So when I look at -3x and -9x, I think, okay, well, I can turn a -3x into a -9x by multiplying by 3. So that's good. When I look at 7y and 5y, I'm like, well, I don't get any common factors together except 35, because 7 times 5 is 35. So this isn't going to work because then I'm going to multiply both by a big number and then it's just going to become a disaster. So I'm going to do these two. I'm going to cancel these two out. So I'm going to multiply my first equation by -3 because I want them to be opposite signs. So if this is a -3x, then I need to multiply by a -3 so it turns into a positive 9x. And so I'm going to rewrite them down here. Positive 9x minus 21y equals 48. And I'm going to rewrite my bottom equation down below like so. So 9x minus 9x, because this one's negative, adding a negative is just like subtracting. So these cancel out. And I'm left with 0 minus 16y equals 64. So I'm left with negative 16y equals 64. I have to divide both sides by negative 16. And I end up with y equals negative 4. So I need to plug that negative 4 back in for y to find x, because when have we ever just asked you to find one thing, right? We always look at x and y as a coordinate point. So if I have my y value, I need to figure out what the x value is. So I'm going to plug in to that first equation just because I chose it. It doesn't matter which one I plug into, like so. So I end up with negative 3x minus 28 equals negative 16. I'm going to add 28 on both sides. So these will cancel out and I'll end up with negative 3x equals, let's see, 28 minus 16 is 12. So equals 12. Then I have to divide both sides by negative 3. And I end up with x equals negative 4. So you watch this as many times as you need to so that you understand how to do elimination. We are really just trying to add the equations together. I personally prefer substitution, but I think the rest of the world really prefers elimination. Elimination is just sometimes tricky for me to wrap my mind around, and I'm not the most confident with it, but I can still do it. So you are going to practice for the rest of class other elimination problems. You can use these in this video to help you. Okay, I'll keep this up in case you missed it, so you can pause. There we go.